Hello everyone, my name is Salvi Kashyap. I completed this internship project under the guidance of Emertxe's internship platform during July-August 2025. The project title is Washing Machine Simulator using PIC16F877A microcontroller. Now we can see the internship goals. We have introduction, internship goal, tools and software used, embedded system, embedded components, embedded C overview. What is microcontroller? PIC16F877A microcontroller. Peripheral used, project roadmap and circuit diagram, project overview, conclusion. That was the table of content. Now we move forward where we can see the introduction. There are the project simulator of washing machine using PIC16F877A microcontroller. This is the type of microcontroller. Implement timer logic, motor control, LED indicator and buzzer alerts. Developed in embedded C, simulated using PICSIMLAB with MPLAB XIDE. Internship goal: learn embedded system and microcontroller interfacing. How we interface the microcontroller. Gain hands-on experience in embedded C programming. Understand real-time control system using timers and interrupts. Simulate a real-world application washing machine. Now we can use here the three software that is MATLAB XID for the writing code, XC8 Compiler for the compiling the code, and for the visualization we can use PICSIMLAB. Now we can move forward. There was the embedded system and the components. What is embedded system? Hardware plus software for a specific task. We can implement the project for hardware and the software for a specific task. They are the components like microcontroller input output devices, memory, timers. Work on real time, reliable, with low cost system. Embedded system basically divided on the two types based on the performance and the functional requirement, and second one is based on the performance of the microcontroller. There was the stand-alone embedded system, real-time embedded system, network embedded system, and mobile embedded system. Based on the performance of microcontroller, there was the three subcategories: small scale embedded system, medium scale embedded system, and sophisticated embedded system. Now we can see embedded system component. There was the microprocessor and the microcontroller. In microcontroller, we have the all devices on a chip, but on microprocessor, we have the only these things. that we have shown: memory, control unit, ALU, data bus, address bus, and control bus. These are the microprocessor and we can use the peripheral by own. Not It's not on implemented on the microprocessor, but when we talk about the microcontroller, it have already the peripherals. It have present on chip like as external ROM, ADC, flash ROM, input output ports, timers, UART, SPI, 12C, ADC. These are the components present on microcontroller. In microprocessor, we don't have these peripherals. We can introduce peripherals by own self. So that's a microcontroller that we study about on the internship. Now we can see embedded C overview. We can use here embedded C used for low level control of hardware. There are the three subcategories: integer, character, and the floating point. In integer, we have the signed, unsigned, int, shortened, longend. Unsigned have int, shortened, longend. Character have correct, signed char, and unsigned char. Floating point have float, double, and a long double. There are the size There are the size and there are the range of the system. And this was the format string that we represent on during the coding. There are the character that have the 1 byte. Its range have -128 to 127 that we represent on the during coding %C for the character. Now we have seen unsigned short that have the 2 bytes, range 0 to 65535 that we use during the code %U. The int that have the 2 bytes, it the range of the int of this, and we are using during the internship %D. That's all are the type of data types that we use on the. Now we move forward on the next slide. What is microcontroller? Integrated circuit with CPU, RAM, ROM, input output ports, and a timers. Control device and embedded application. For example, PICSIMLAB, in which we have developed the code and have the hardware. We can see PIC16F877A have CPU, memory, input outputs, control bus, address and data bus that we can see here. What is the PIC16F877A? We can see on next slide. A microcontroller. This is the 8-bit microcontroller by Microchip. 33 input output pins, USART, timers, ADC, 8K program memory, suitable for real-time embedded system. You can see here it have the 14 pins that we used for another program. Every pin have different work with a different name. we have the 33 input output pins USRT, that is Universal Synchronous Asynchronous Real Time Operating System, timers, analog to digital converter, 8K program memory, that we see here their block diagram of pin description. Now we will move forward. Now we can see the peripheral used on embedded system. This was a DIP switch for input setting timer, LED status indicator, DC motor simulate drum rotation, and the buzzer signal completion. Now we have the project roadmap. This was our project where we have embedded C, operator, function, arrays and pointer we used for the coding embedded C on microcontroller basic definition memory type we can see PIC programming on using of LEDs, switches and interrupts, implementation, timer setup, motor and the real-time status show on CLCD. Screen show was cycle, motor and the buzzer in action. We can see on after the project roadmap, we can see the project overview, how we code on the project and have and have the run program. The process how we can perform the our project line by line. There was the embedded system example washing machine that we have seen it have the ROM, RAM and the control units in which use the PIC microcontroller and the processor RAM ROM with the software input buttons that we used on the washing machine for display the switches for dry clean for moving the fan and so on. We have display motor that we see after the coding. Now we can see the overview what's about the project. According to project roadmap, we can see their overview on the video. Now we can see project overview where we have the project like header file, import files, link file, source file, libraries and loader availables. So starting part of the project we can see the here we program this slab. We can run the program and have this one, and as you see this build successful total here. Now it's generated the file on using the MATLAB IDX and it compiled with using the XC8 compiler. Now you can see it compiled and open the PICSIMLAB that have the full screen of the PICSIMLAB. It have the screen, fan, microcontroller, switches, and so on. Now we can see loaded the hex file. As you can see, you just switch on and it have powering on the washing machine. You can see on the display that we code using the MATLAB. Now it have daily, heavy, dedicates. It's a washing program. And you can see more option when you scroll down. Now here the RB1, RB0, RB2. These are the switches. RB3, RB4, RB5, RB A5 are the switches. Now you can see washing program like stain wash, eco cotton, woolens, bedsheet, dry, wash, aqua store, daily. You can see lots of option here. Now select any function with the long press, like we will press the button and we have the uh, now I have long pressed this key. We have the heavy option like auto, low, medium, where we can see there are the water labels. Auto. Now we can change and we will see the medium, high, max, water label. These are the different water label we can use on the simulation. We can just press and have the their different water labels. Now we have the and I have forward now I have forward these to next screen, and this was started the function. Now I I switch the I switch the I switch it and now it's started. You can see the time is set there, that is 49, 48, 47. After the time finish, it have buzzer, or for starting the switch it have SW5, and pause the switch it have SW6. After completing its time, it's just have the buzzer music that you can listen. Just waiting for the finishing time, and that time the clothes are washed up. As we now the function is changed. There are washed, now it's rinsed. This is totally this is doing by own. We can just see the display and have the full program. These are rotating the our washing machine, how it take time. Now you can see a spin. Now we can see the conclusion of our project. Here, so it's line by line process. Implemented real-time control logic. It completed simulation of washing machine using PIC16F877A. Used real-time components like timer, interrupts, LCD, keypad. Learned embedded C and simulation tools, future upgrade IoT integration, GSM alert system. This was the conclusion of our project that we can see here line by line steps in which we developed the washing machine. Thank you for watching this video. And thank you to Emertxe for giving this wonderful opportunity to us.